Hi, this is Emilio Ortiz, and this is my final product, the timer or mini timer that I was building for EE450 Capstone Design by Dr. Professor Carmichael. In this class, I propose a project of making a digital timer controlled by a microcontroller, and I'm ready. I'm ready to show that my project is working. I create a program on PBasic, which is right there on the computer monitor, and that was the final of three actually programs that I use. I create two other programs to basically test my circuit. On the first one, I test the buzzer and the rest of the computer components, or the microcontroller that is using basic stamp, on which I have I'm using a home board. You can see here a home board with basic stamp 2. I'm using also 7-segment LED display. I'm using a buzzer, which is a piezo speaker, and I'm using actually one of each component that I just mentioned. I'm gonna get this out of the way so it can be seen better. As you can see down there, there's a potentiometer too, many resistances. Actually it's 2 of 220 ohms and 8 of 1 kilo ohms, which actually in reality I measure with my meter right there every single resistance or resistor, I should say, and of course in reality they come close because of the tolerance to the values that they're supposed to be in theory. So as I was saying, I have 2 of 220 ohms resistors, 8 of 1 kilo ohms resistors, and 1 of 10 kilo ohms, 10 kilo ohms resistor, or 10,000 ohms resistor. You can see the basic stamp right there. This is the peak. I'm trying to get a closer look of the peak. Is right there on the center. Let me show you with a tool that I have over here. I don't want to touch too much the board, so I don't damage with the static electricity or something. Make a short circuit on the board. But this is basically right here. That is the peak that I'm using from Parallax, which is peak 16F57. So with this project, what I'm trying to do is I'm gonna explain in simple words the project. The reason that I have a timer here, which you can see is broken, but it's still working, is because I'm gonna compare this timer over here, which is complete. It's not a mini timer. It actually have a LCD display, so you can see right here the minutes in the tenths and the seconds in the tenths too. So you can see the 02 minutes and 00 seconds. I can use any minutes up to 9 because my project, my mini timer, will work up to 9 minutes and will go down to 0. So when this is what I'm gonna do. I'm gonna use a program that I wrote on my computer, and this program is basically um, the brain, or what makes the microcontroller goes to go into the basic stamp and program my PIC in order to use the incoming and outgoing pins to control my components. I apologize for my English, but on basic words, I don't want to mix my English with my Spanish, but in simple words, what I'm doing here is with this serial over here, with the serial cable, I'm gonna enter the program into the PIC, as I mentioned before, 16F57 from Micro, which is a company that create those kind of microcontrollers. Let me explain here. Of course, I know the professor knows all this, but as a student, I have to explain that this is a reset button that the stamp, the basic stamp or board, will use. So once I get the software from my computer to my basic stamp, if I want to start all over again the program, I don't have to go into the computer and enter it through the serial cable again. I just have to press the reset button and the software will start all over again. The reason I'm using 7 segment LED is to show the user the minutes that is left on the timer from 9, or from 0 up to 9. They will go down. The details, the technical details, I will explain better in the documentation and final project. But this is just this video is just a proof that me, Emilio Ortiz Jr., create this board for the class. Also, I have, and also that I understand, of course, what is going on, because I was going to create a digital clock, but I had problems finding more 7 segment LEDs. I was ready to make a change and use what originally was my idea, LEDs per se and not 7 segment LEDs, but that's another story. Because time constraints, I decided to, and I was approved by the professor to make this modification, because it's the same principle for the digital clock. Okay, with this potentiometer right here, I'm gonna show you with my finger. I'm gonna control with this potentiometer the minutes that are gonna be shown on the LED, on the display, on the 7 segment display LED. With this push button over here, which you're gonna see on the schematic how all this is connected to the stamp, I'm gonna start the timer. When I start the timer, you're gonna hear a sound that tells me that the timer has begun. This piece over here, the buzzer, is the one that is going to make that sound. Well, I guess that explains pretty much it. So I think it's time, no more talking, for doing what we're supposed to do. I'm going to attach now the 9 volts, which actually is this board is pretty much consuming a lot of energy, or maybe my batteries are not good, because I start with more than 7 volts, and it's down to, I noticed this is now down to 6 volts, maybe because all the tests that I have been doing with this board, and sometimes I forget to disconnect the power. So let's start to connect the power over here. You can see that because there is no short circuit, the board already is turning a light right there, right here, showing that this is working. Actually, since I already put in the program, the stamp is already, or the LED is already showing a number 2, which I'm gonna change that because I want to show all the process, the complete process. So now I have to hook up, and I'm sorry for not making a professional video, but this is not what I usually do. I'm gonna put over here, so bear with me please. That's the serial connected over there. So now I'm gonna run. Let me put the timer over here because I'm gonna go up to 2 minutes. Let me show you something over here. I'm gonna run the program on this area over here, the program of Basic Stamp, the software. I'm gonna press run, and you're gonna see that the LED is actually disappear and appear again. That is resetting the program, which I didn't actually have to do because the program is already in, the software is already in, so I can use it by just pressing the reset button, and it will be the same thing. So once I get that, I can disconnect the serial cable because the program is already in, or to show that I'm actually Emilio Ortiz. That is my student number and the course, of course. And now what I'm gonna show is that I can go ahead and with the potentiometer over here change actually the display from, I hope that the potentiometer doesn't move from place, or I will be having some problems over here, so I have to be careful. But I'm gonna move this till it shows 0, and you can see that I can go control the display from 0 up to 9, which is the maximum minutes that this mini timer can operate. I'm not gonna make this test from 9 minutes. I'm just gonna go ahead and put it to 2 minutes because I don't want to make this video too longer. So now I have to be careful here not to make a short circuit. Now I'm gonna press with something that I have over here, a pen that is actually plastic and will not make any kind of short circuit. I'm gonna press the button, this button over here, the push button. Just please listen. I don't know if this telephone is gonna catch with the video the sound, but I hope so. So listen when I press, because I'm gonna press also the timer over here at the same time, or at least I'm gonna try to do it at almost at the same time. You're gonna listen to a sound that is gonna show you that I have started the timer for 2 minutes. Listen up. Okay, so the timer just start, and I start my second timer, which is gonna compare to this one. So we have now, actually this one, the homemade, the one that I created with the circuit and the microcontroller, is supposed to go faster, a little bit faster than the second one. So it's actually less than 1 minute and 30 seconds Um, and why is that? Because I pressed the push button to start my mini timer before the other, or the um, buy the bot timer, or the commercial timer. So now it's going to be less than 1 minute. Supposed to be less than 2 minutes. We'll see. There you go, 1 minute, and over here is 1 minute. So they're pretty close actually. Pretty close. So we'll see. 42 seconds. So, and at the end, the the circuit that I create, you're gonna see that when it's almost time to be done, it's gonna make some sounds that I put on the software to let the user know that the timer is ending, is going to zero. Less than 10 seconds. As you can see, I have created the final project for the capstone design. Is a success. So I hope this shows that I have the skills necessary to create what an electronic engineer supposed to create. Thank you very much. God bless.